We're going to discuss past year 2013 and 2014, which would be your question 8 in your past year. In a titration experiment at 25 degrees Celsius, a total of 30 ml of 0.1 molar sodium hydroxide was added dropwise into a conical flask containing 25 ml of 0.1 molar HCl. So from this we know that your titrant would be your sodium hydroxide because it is added dropwise into your conical flask which has HCl. Okay, next we add a few drops of an indicator. Show the variation of pH of the solution before the addition of sodium hydroxide at half equivalence point, at equivalent point, and at the final volume of the titration. Next, after we are able to identify all the points, we need to sketch a graph of pH against the volume of sodium hydroxide. You are given the Kw already because it is a constant. So next, the question asks what is acid-base indicator, and by referring to the table below, your table of indicators, suggest the most suitable indicator to be used in the titration above and give reasons. When the question mentions suggest the most, okay, please highlight the word most. It means that I just need one indicator only. So let's check how many questions do we have in this question. First, we need to find the pH before the addition of NaO, next at the half equivalent, at equivalent, and the final value of titration. Lastly, sketch a graph of it, and then define your acid-base indicator, and then lastly is to suggest the most suitable indicator. So you are given this indicator with below pH range, so we only choose one. So this is my summary because I want to fill in what is the pH and what is the volume of sodium hydroxide used for us to get to this point. First thing first is we need to calculate the mole by using the formula of molarity. So the mole for sodium hydroxide would be 0.1 times 30 divided by 1000. So that would be 3 times 10 to the power of minus 3 mole. And the mole for HCl would be 2.5 times 10 to the power of minus 3 mole. So first question is to find the pH before the addition of NaO. So first is the pH before addition. So first, we don't add any sodium hydroxide first. So the volume of sodium hydroxide used is equal to 0 ml. Why we need to find the volume of sodium hydroxide used? Because remember back in my video I told you that the y-axis would be the pH, for the x-axis that would be the volume of titrant add. So in this case our titrant is sodium hydroxide. So that's why we need to find the volume of sodium hydroxide used. So what do we have in our conical flask? We only have HCl, right? So write a complete equation of your HCl, which is a strong acid, so it dissociates completely to form H plus and Cl minus. Since this is an acid-base titration, so we know that our formula to find pH would be negative log H plus. And we know that the concentration in HCl is 0.1 molar. So the concentration of H plus would be 0.1 molar as well. So we can find the pH directly. The pH would be 1. So for first point that we need to sketch is when the pH is 1, the volume of sodium hydroxide used would be 0 ml. Second point is to find the pH at half equivalent, which means our equation would be the 1 mole of sodium hydroxide is equivalent to half mole of hydrochloric acid. So what is the mole for our sodium hydroxide? So that would be 2.5 times 10 to the power of minus 3 divided by 2. So we've got the mole of sodium hydroxide to be 1.25 times 10 to the power of minus 3 mole. So after we find out the mole at half equivalent, so what is the volume of sodium hydroxide used at half equivalent? So just divide the mole with the molarity. which is 0.1. So the volume of sodium hydroxide used would be 12.5 mil. We're not finished yet. So look back. I've already turned on our stopcock. So which means sodium hydroxide and hydrochloric acid will react together and form reaction inside the conical flask. So we need to find the new molarity. So HCl will react with sodium hydroxide to form the salt NaCl and water. Okay, remember our RCFN table? Yeah, we need to do that for this question. So what is the initial mole, change, final, and lastly our new molarity? The initial mole for HCl, we've already calculated this before. That would be 2.5 times 10 to the power of minus 3. But for the sodium hydroxide, remember we add the sodium hydroxide. So we've got new mole of it, which is 1.25 times 10 to the power of minus 3. We don't have any salt formed. So NH2O dash. And the change in mole minus for reactant or add for product, the smallest mole between acid and base. So look at here, which one has a smaller mole between your acid and base? That would be your base. So for the change, minus 1.25 times 10 to the power of minus 3. This one would be the same as well. So you find a mole. That would be 1.25 times 10 to the power of minus 3, and this one is 0, and this one is 1.25 times 10 to the power of minus 3. For the new molarity, remember that we need to divide the final mole with the volume total. So look back at your titration. The total volume would be the volume of acid and the volume of base in conical flask only. So we need to find the total volume for the pH at half equivalent, and that would be, what is the volume of acid in our conical flask? That would be 25. And what is the volume for sodium hydroxide that we titrate? That would be 12.5 mil. So the volume total would be 37.5 mil. Okay, remember to convert it to liter, so they would be 0.0375 liter, because we want to use this to calculate, to find the new molarity. So our new molarity would be 0.03 molar and 0.03 molar. Okay class, this is not a buffer solution, right? So the formula to find the pH is still the same, negative log H plus. So where can we get our hydrogen? We got our hydrogen ion from HCl, right? So what is the molarity for your hydrogen? It will be 0.03. So your pH would be 5.52. So we've got our second point, which has a pH of 1.52 and the volume of sodium hydroxide to be 12.5 mil at half equivalent point. The third point is to find the pH at equivalent point. So you must know this. At equivalent point, the concentration of hydroxide ion is the same as, that is, hydrogen ion. So from this equation, we've done this before at earlier in chapter 7. So where can we get these both equation? That is from the dissociation of water. So we form hydrogen ion and hydroxide ion from the dissociation of water. So can we find the concentration of hydrogen ion? Yes, we can, by using the formula of ionization of water. So we've got 1.0 times 10 to the power of minus 14. So this one would be X, the same with concentration OH minus. We are not given both information. So the square root is Kw. So you've got the concentration of hydrogen ion as 1.0 times 10 to the power of minus 7. So the pH would be negative log H plus. So your pH would be 7. So remember in my first video about acid-base titration, and how we need to find the molarity or the volume of acid or base at half equivalent by using the MAVA equal to MBVB. What do we need to find is the volume of base used. Okay, so we've got the molarity already. Molarity of acid and the volume as well as 25 times 0.1 equals to the molarity for base is 0.1 times VB. So your volume of sodium hydroxide used to get to equivalent point is 25 mil. So we've already got our third point with a pH of 7. Our sodium hydroxide use would be 25 mil. For the pH at final volume of sodium hydroxide, so we've used all the sodium hydroxide, so the volume of sodium hydroxide used would be all of it 30 mil. Our total volume would be, so the volume of acid is 25 times 30, that would be 55 ml. So now let's make our table between HCl, sodium hydroxide. Our initial mole is still the same. So for HCl it will be 2.5 times 10 to the power of minus 3. For sodium hydroxide it will be 3 times 10 to the power of minus 3. Okay, because we've used all the sodium hydroxide. For the change, okay, which one is the smallest mole? Yeah, that would be your acid. So for the change, you just minus and add all with the mole of HCl. So your final mole for HCl will be 0. This one would be 5 times to the power of minus 4. And this one 2.5 times 10 to the power of minus 3 divided by, okay, we need to find the new molarity. So the volume total is 55 converted to liters. So we've got 0.055. Okay, so our new molarity for sodium hydroxide will be 9 times 10 to the power of minus 3 molar. And your salt would be 0.045 molar. So what do we have in the table? We've only got the concentration of sodium hydroxide the concentration of hydroxide ion from sodium hydroxide. But for pH, we need to find the concentration of H+. Okay? So we're going to use the formula of Kw. Okay? So our concentration of H+ would be 1 times 10 to the power 1 times 0 times 10 to the power of minus 14 divided by 9 times 10 to the power of minus 3. So we've got the concentration of hydrogen ion as 1.1 times 10 to the power of minus 12 molar. So our pH for at final volume of titration would be 11.95. So made a summary. So when the pH is 11.95, the volume of sodium hydroxide used would be 30 mil. So next question is for you to sketch your graph. Yes, so we already found all these 4 points. So these are all our points, and these are the x and y axis of your titration curve. So let's point your curve. So when the pH is 1, the volume of now is 0. When the pH is 1.52, so it must be around here, the volume of sodium hydroxide used would be 12.5. That would be around here. When the pH is 7, the volume of now used would be 25. And when the pH is 11.95, the volume of now would be 30. So now connect all your dots. And one more thing, class, please label all your points. So this one is at half equivalent. This one is at equivalent point. And this one at final volume. And the first point is before addition of sodium hydroxide. So this is how your titration curve gonna be. So it goes upwards because we've got a strong acid in our conical flask. What is acid-base indicator? So it is the dye that has different colors in acidic and basic conditions. So this already got 1 mark, and it is then used to detect the endpoint of acid-base titration by a change in color. And then next, the last question is to suggest the most suitable indicator. So look at our graph. So at equivalent point, at this point, the pH is 7, right? So we've got phenolphthalein, chrysolite, bromothymol blue, or litmus paper. So all of these can be used, but which one is the most specific? The phenolphthalein is already out of our option because the pH starts with 8. Meanwhile, our pH at equivalent is 7. So, and chrysolite is out of as well because the pH is, we start with a pH of 7, so we're not able to determine specifically the color change. And for bromothymol blue, okay, it has a range between 6 to 7.6, which is good for us. But for litmus, okay, so the pH range is between 4 to 8. It has a wide range of color change. So the most suitable one would be the bromothymol blue. And the reason is because the range covers the end point of titration. And it also has abrupt or a sudden color change, which is this thing that goes from yellow to blue. Okay, so that's how you've got all 20 marks for this one questions only. To summarize, ICE table is for KP and KC and also KA and KB. Okay, so we know that from KC, KA and KB it is in molarity. And the next table is your ICFN table, that is for buffer, solution and your titration. For buffer, your change, you should minus or add the disturbance, which is either your H plus or OH minus. But for titration, your change, you should add or minus your smallest mole between acid and base. We only did the ICFN table for titration to find the pH at half equivalent and at final volume. Okay, so the rest for pH before adding your titrant and at equivalent one, you just find it as usual through the dissociation equation. So this is the summary for which tables should be used in your PSPM.